Hi everyone, at Digital Colmer here. So I had a fantastic question from a student today. They wanted to know about some on-premise F5s which perform a LTM and a GTM function. How do we do that in the AWS cloud? Well, there are two services we can talk about, elastic load balancers, and there are 4 types, and I'm going to cover 2 types today. And there is also Route 53. So let's start with Route 53. So the Route 53 service is suitable for load balancing between regions. So we can direct traffic to, say, the Sydney region and the Melbourne region using a routing policy. So that takes care of the global load balancing aspect. The local load balancing is accomplished by elastic load balancer. And so we have 4 different types of load balancers, 2 that I'm going to mention today. The application load balancer, which works at layer 7 of the network stack, which listens for HTTP and HTTPS and gPRC traffic. And then we also have a network load balancer that works at a lower layer of the network stack. Therefore, the packets are smaller and it can process them much faster. It works at layer 4 of the network model, the OSI network model, and it listens for TCP and UDP packets. So let me show you an architecture diagram and just talk through some of those components. So let me see if this is going to work. Here we go. Here's my beautiful sketch. So we can see at the top here, Route 53. Route 53 is designed to distribute traffic between 2 regions. So here we can see we have the Sydney region, and over here we have the Melbourne region. Once traffic is directed to a region, it is intercepted by an application load balancer in this example. The application load balancer has a listener installed. That listener works at layer 7 of the network stack, listening to HTTP and HTTPS traffic. Depending on the type of traffic it intercepts, it then processes that traffic according to certain rules and redirects that traffic to what we call a target group. And so this target group here represents 4 EC2 instances by the 4 dots. And that is processing now web traffic. We have the same over here in Melbourne. Now, the next layer of architecture stack, we are then forwarding our web traffic to a network load balancer. The network load balancer works at layer 4 of the networking stack, listening for TCP and UDP packets. We do this by installing a listener that listens on a certain port for the packets that we want. And depending on what it listens to, it then processes the traffic according to rules and sends them to the appropriate target group. And so here we have an example of a target group with 4 EC2 instances installed. I haven't drawn this down, but we could then connect this to databases. And this is our application layer. So we have our web layer serving processing web traffic, and then we have our app layer processing application traffic. And this is an example architecture of how we can use Route 53 to send traffic between 2 regions, application load balancers to send traffic to web servers, and then to use a network load balancer to forward traffic from our web servers to our application servers. So lots of key learnings there. Route 53, installing a listener and processing the traffic with rules on our application and our network load balancers. The concepts here of target groups, and not forgetting application load balancers working at layer 7, intercepting HTTP and HTTPS traffic, and layer 4 for network load balancing, intercepting the TCP and UDP packets. So I really hope that you've enjoyed that little tutorial. Hopefully I explained it really super clear. If there's any doubt, I've also put that into the tweet just above, so you can read not only about ALBs and NLBs at the application and network layer, but I've also expanded on gateway load balancers and classic load balancers and when and why you should use those. So I hope you all have a fantastic day. I hope you gained some value from this video. This is Digital Colmer signing off. Now, where's that button?